Hi everyone. In this video I'll talk about a classic problem used to test newly proposed synchronization schemes called readers-writers problem. Suppose that a database is to be shared among several concurrent processes. Some of these processes may want only to read the database, whereas others may want to update the database. We distinguish between these two types of processes by referring to the former as readers and to the latter as writers. Obviously, if two readers access the shared data simultaneously, no adverse effects will result. However, if a writer and some other process, either a reader or a writer, access the database simultaneously, chaos may ensue. The readers-writers problem has several variations, all involving priorities. The simplest one, referred to as the first readers-writers problem, requires that no reader be kept waiting unless a writer has already obtained permission to use the shared object. In other words, no reader should wait for other readers to finish simply because a writer is waiting. The second readers-writers problem requires that, once a writer is ready, that writer perform its write as soon as possible. In other words, if a writer is waiting to access the object, no new readers may start reading. To ensure that these difficulties do not arise, we require that the writers have exclusive access to the shared database while writing to the database. This synchronization problem is referred to as the readers-writers problem. Since it was originally stated, it has been used to test nearly every new synchronization primitive. A solution to either problem may result in starvation. In the first case, writers may starve, in the second case, readers may starve. For this reason, other variants of the problem have been proposed. Next, we present a solution to the first readers-writers problem. In the solution to the first readers-writers problem, the reader processes share the following data structures. The binary semaphores mutex and RW mutex are initialized to 1. Read count is a counting semaphore initialized to 0. The semaphore RW mutex is common to both reader and writer processes. The semaphore RW mutex is common to both reader and writer processes. The mutex semaphore is used to ensure mutual exclusion when the variable read count is updated. The read count variable keeps track of how many processes are currently reading the object. The semaphore RW mutex functions as a mutual exclusion semaphore for the writers. It is also used by the first or last reader that enters or exits the critical section. It is not used by readers that enter or exit while other readers are in their critical sections. If a writer is in the critical section and n readers are waiting, then one reader is queued on RW mutex, and n1 readers are queued on mutex. Also observe that, when a writer executes signal RW mutex, we may resume the execution of either the waiting readers or a single waiting writer. The selection is made by the scheduler. The readers-writers problem and its solutions have been generalized to provide reader-writer locks on some systems. Acquiring a reader-writer lock requires specifying the mode of the lock, either read or write access. When a process wishes only to read shared data, it requests the reader-writer lock in read mode. A process wishing to modify the shared data must request the lock in write mode. Multiple processes are permitted to concurrently acquire a reader-writer lock in read mode, but only one process may acquire the lock for writing, as exclusive access is required. Reader-writer locks are most useful in the following situations. 1. In applications where it is easy to identify which processes only read shared data and which processes only write shared data. 2. In applications that have more readers than writers. This is because reader-writer locks generally require more overhead to establish than semaphores or mutual exclusion locks. The increased concurrency of allowing multiple readers compensates for the overhead involved in setting up the reader-writer lock. That's it. Thank you for listening.